So we'll continue with another example here in section 2.3. We're still in part A. Here's another division problem to do. So let me go ahead and set it up. 2x minus 1 divided into 6x cubed plus 11x squared minus 17x plus 8. We always start with just the first terms, and our thought process is what's 6x cubed divided by 2x? Let's see, 6 divided by 2 is 3. X cubed divided by x is x squared. One thing that I didn't really mention with the first example, because we had so much to think about, but it's probably good to say, is you'll notice that as I'm writing out the answers, I'm kind of taking care to line up like terms. Notice the answer 3x squared I wrote above the x squared term here. You can actually save yourself some mistakes sometimes by being careful with that lining up. All right, we'll take our 3x squared, and we'll multiply it by 2x minus 1. And I'm going to put that right here. 6x to the third minus 3x squared. Remember that you're subtracting now, which will make that a negative, and minus a minus makes that a positive. So the x cubed terms are gone, and I end up with 14x squared. And then I'll bring down the last two terms. All right, that's one complete cycle. Second cycle, 14x squared divided by 2x. That'll be 7x to the first, so I'll write that up here in the quotient. And then I need to take 7x and multiply by 2x minus 1. That gives me 14x squared minus 7x. Oops, and I forgot to indicate, but I am putting that product right there. To subtract, that one becomes negative, that one becomes positive. The x squared terms add up to 0, and I'll get a negative 10x right here. And bring down the plus 8. All right, that was a second complete cycle. We start over again. We take our negative 10x, divide it by that 2x. That'll give me a negative 5, and the x's just divide out. So just negative 5. I'll take that negative 5 and multiply it by 2x minus 1. And that's going to go right there. Negative 10x plus 5. Subtracting here makes that a positive and that a negative. Negative 10x plus 10x is 0, and 8 minus 5 is 3. We know we're finished dividing at this point because 3 is just a constant, which has a lower power than 2x to the first. So I know I must be finished. I could write this answer as the quotient, 3x squared plus 7x minus 5, with remainder 3. Mathematically, however, we typically prefer to put our quotients back into fraction form. So another way to write this answer would be 3x squared plus 7x minus 5 plus that remainder 3 still hasn't been divided by the original 2x minus 1. So if I write it in its fraction form, I'm saying, yep, that still needs to be divided by 2x minus 1. I just can't go any further with my long division process. Since this division did not come out evenly, we would have to conclude that 2x minus 1 is not a factor of our original polynomial, and I couldn't write a factored form based on what we've done here. All right, let's do one last example. A couple of things that I wanted to point out that can sometimes happen with this last one. First of all, notice here's one where we're dividing by a quadratic, so that's a little bit different. But the second thing that I wanted to point out to you is that when you look at the numerator and think about the descending order, we skip from x to the fourth to x squared. There were no x cubes, which is what that missing term means. When we do our division, we want to include missing terms by putting them in with a coefficient of 0. So when I write out my division process here, I will take this x squared minus 2x plus 2 and divide it into x to the fourth, and then I'll say I have 0 x cubes plus 5x squared plus 4x plus 9. Other than that, the division process is the same. So we'll start with the first terms, x to the fourth divided by x squared, which is x squared. I'm going to line up my x squared term over here. And then x squared times all of that. Is going to give me x to the fourth minus 2x cubed. And now you can see why it was important that we put the 0x cubed in. I wanted to keep my like terms lined up. And finally, a plus 2x squared. I am subtracting, so that becomes negative, positive, and negative. X to the fourth terms add up to 0. I have a positive 2x cubed, and then a plus 3x squared. I will bring down the remaining terms. And then we're ready to divide for the second cycle. 2x cubed divided by x squared. Well, that'll be 2x to the first. So I'll put a plus 2x here. And then I take my 2x and multiply it by the divisor. And I'm missing my pattern here. There we go. Put that one there. When I multiply, I get 2x cubed minus 4x squared plus 4x. All right. Once again, I'm subtracting, so minus, plus, minus. No x cubeds left. I have 7x squared. There are no x's left. But once again, I don't really want to leave that spot blank, so I'm going to write it as a plus 0x, and then plus 9. All right, looks like I got to divide again. 7x squared divided by x squared, something that can be done. And that would make that just plus 7. So I'm going to take that 7 and multiply it by x squared minus 2x plus 2. That will give me 7x squared minus 14x plus 14. And subtracting one more time makes that negative, positive, negative. I have no x squareds left. I have a positive 14x and a minus 5. I am done dividing. I can tell that a couple of different ways. For one thing, if I were to look at what the next step technically would be, I would be taking that 14x and dividing it by the x squared, which isn't going to come out with a nice answer since the power on the top is smaller than the power on the bottom. So I know I'm done. Also, once my last term in the division is a constant, that's another signal that I'm going to be done. Did not come out evenly, so let's go ahead and write the answer with the fractional form of the remainder. The answer was x squared plus 2x plus 7. Plus I take my remainder, 14x minus 5, and that's still divided by x squared minus 2x plus 2. So once again, since the division did not come out evenly, I could not write the factored form of my numerator using what we've done so far.